We're going to start off with some vocabulary. An experiment is an action or a trial, activity, any of those things. We usually call it a trial in statistics that has varying results. Meaning we can do this and we might get different answers. An example of this would be rolling a die. The outcome is a possible result. Of the experiment. That might be like rolling a 4. The sample space is the set of all possible outcomes. So for our example here, rolling a regular 6-sided die, we could get a 1, a 2, a 3, a 4, a 5, or a 6. So if we have multiple actions, it can be a little bit more difficult to keep track of things, so we use something called a tree diagram. And the tree diagram, well, let's just do one. So if we pick a digit 1 through 8 and then toss a coin, flip a coin, I am going to have, from my original start, I'm going to have 8 possibilities. So this is what I'm rolling or choosing. Then from each of those, I could have chose one, and then I can get heads or tails. Or I could have chose a 2, and then I might get heads or tails. Or 3, heads and tails. 4, heads and tails. 5, heads or tails. 6, heads or tails. 7, heads or tails. 8, heads or tails. And if I count along the bottom here, these are all the possible outcomes that I had. So I had a possibility of 16 outcomes. The sample space is a list of those things, and typically we write them all out. This is, I could have 1, then heads, 1 tails, 2 heads, 2 tails, 3 heads, 3 tails, 4 heads, 4 tails, 5 heads, 5 tails, 6 heads, 6 tails, 7 heads, 7 tails, 8 heads, or 8 tails. And if I count all those, I have 16. So if I randomly guess the outcome, or randomly guess the last 3 multiple choice questions on a test, and there are 4 options, then I would have options 1, or question 1, 2, and 3, which might not be the question number, obviously, but we'll just number those of the last 3. Then I could have A, B, C, or D. A, B, C, or D. A, B, C, or D. So you can notice that I have 3 options here and 4 for each of those, and my number of outcomes actually is simply 3 times 4. And then I'm going to write out my sample space. So I could have 1A, 1B, 1C, 1D, 2A, 2B, 2C, 2D, 3A, 3B, 3C, 3D. And writing out 12 or 16 is not too bad. When we look at some other ones, let me erase this. If I choose a day of the week and then choose a letter, well, let's number the days of the week. So if I say that 1 is Sunday, 2 is Monday, 3 is Tuesday, 4 is Wednesday, 5 is Thursday, 6 is Friday, and 7 is Saturday. Then I could have my choices across the top. 1, 2, 3, 4, 5, 6, 7. So those are my first step. Then I'm going to choose a letter from the word math. So each of these has 4 options. Sometimes you have to be creative in how you fit it into your space. Math. And so I have 7 possibilities here, 4 here, and my total possibilities is going to be 28 outcomes. Your sample space is going to be writing out 1M, 1A, 1T, 1H, 2M, 2A, 2T, 2H, 3M, 3A, 3T, 3H, etc. Ordinarily, they would not let you do this. You would want to list them all out. I feel like 28 is a lot to list, and I think we'll be okay if we don't list it. On a test, I promise I won't give you one that has 28 options that you'd have to write out. But like we said, if you can take 2 of those activities and you can figure out that one activity occurs M ways and the other one occurs N ways, then both activities can occur M minus N ways. And the ways that you might see this show up is if you choose a month of the year, which is there's 12, and digits 1 through 9, which there's 9, you get 12 times 9, which gives you 108 outcomes. I also don't want to write down 108 of them. Choosing a letter of the alphabet, 26, then flipping a coin or tossing a coin, so that's 2 options. That gives me 52. These are the most popular ones that you see on tests where you choose a pair of pants, a shirt, and a belt from 3 pairs of pants, 5 shirts, and 2 belts. Well, you just multiply them. 3 times 5 times 2, and that gives us 30. If you roll a standard die 4 times, you have 6 outcomes each time, which is 6 to the 4th power, not 6 times 4. And if you wrote that out, it would be 1,296. I like to think of it as multiplication, although it is using exponents. Choosing one student from a class of 32 and another from a class of 27, that's going to be 32 times 27, which is 864. You guys should check my math. We have a spinner to the left. It's got 16 options on it. We're going to spin it 3 times. So we're going to have 16 times 16 times 16 possible outcomes, which is 4,096. Tossing a coin 5 times. It's got 2 options each time. So 2 times 2 times 2 times 2 is 32. Using the numbers 0 through 9, so those 10 of them, To make a 4-digit password, it doesn't say that it has to repeat or not repeat, so I'm going to assume that they don't repeat, or that they can repeat, and I would have 10 times 10 times 10 times 10, which gives us 10,000 as our option. And choosing a perfect square that's less than 50 and a letter from the word signature. Well, there are 9 letters in signature. There are 7 perfect squares less than 50, so 7 times 9 is 63.